This is a functionality introduction of Depth Insight Velocity and Attribute Modeling module. We will build the velocity and attribute model based on this structure model. Its area is 22 by 23 by 1.7 kilometers with 20 reverse faults. Based on this structure model, there are 3 ways to populate the velocity and attribute model for each zone: proportional, follow top, and follow base. To build the velocity model, you can use seismic velocity cube, well data, or velocity spectrum data respectively, or a combination of this data. For example, we can use the interval velocity data, which is extracted from the velocity spectrum data. There is some obvious abnormal velocity data. We can edit it to make the velocity data more reasonable. One way is to select the abnormal data and delete it. The second way is to define time-related linear function or fixed value for the abnormal data. The third way is to specify a scope for the data value. Then all the data value will be within the scope. After the filter, we can smooth the data. There are several population methods to improve the precision of the velocity model. Under the constraint of the structure model, populate the data based on area referring to the existing data to generate a 3D velocity field. The interval velocity changes obviously around the fault areas. Calibrate the 3D interval velocity field with real velocity to improve the precision and resolution of the interval velocity field model, which guarantees a reasonable horizon structure framework after time depth conversion. From the time depth conversion error statistics, we can see the velocity model built with well seismic combination is more reliable and accurate. Based on the structure model, we can build attribute models with well logs and other raw data. For example, we can build an acoustic impedance model. There are several population methods. Under the constraint of the structure model, populate the data abstract area referring to the existing data to generate a 3D attribute model. As we can see, the attributes change obviously around the fault areas. The output low-frequency model can be used for inversion. From the inversion section, we can clearly see the horizons and fault structures. At the margin of reverse faults, the attributes are clear and has no transitional area. A sequential slice can be easily and quickly generated, which clearly represent the depositional features. That's all about the velocity and attribute model. If you have more questions, please feel free to contact us.